Light pollution, also known as photopollution, luminous pollution, is excessive, misdirected, or obtrusive artificial light. Pollution is the adding of added light itself, in analogy to added sound, carbon dioxide, etc. Adverse consequences are multiple, some of them may not be known yet. Scientific definitions thus include the following: the degradation of photic habitat by artificial light, the alteration of natural light levels in the outdoor environment owing to artificial light sources, the alteration of light levels in the outdoor environment due to man-made sources of light. Indoor light pollution is such alteration of light levels in the indoor environment due to sources of light which compromises human health. The introduction by humans, directly or indirectly, of artificial light into the environment. The first three of the above four scientific definitions describe the state of the environment. The fourth one describes the process of polluting by light. Light pollution competes with starlight in the night sky for urban residents, interferes with astronomical observatories, and, like any other form of pollution, disrupts ecosystems and has adverse health effects. Light pollution can be divided into two main types: unpleasant light that intrudes on an otherwise natural or low light setting, excessive light that leads to discomfort and adverse health effects. Light pollution is a side effect of industrial civilization. Its sources include building exterior and interior lighting, advertising, commercial properties, offices, factories, street lights, and illuminated sporting venues. It is most severe in highly industrialized, densely populated areas of North America, Europe, and Japan, and in major cities in the Middle East and North Africa like Tehran and Cairo. But even relatively small amounts of light can be noticed and create problems. Since the early 1980s, a global dark sky movement has emerged, with concerned people campaigning to reduce the amount of light pollution. The International Dark Sky Association is one non-profit advocacy group involved in this movement. Impact on energy usage. Energy conservation advocates contend that light pollution must be addressed by changing the habits of society, so that lighting is used more efficiently, with less waste and less creation of unwanted or unneeded illumination. Several industry groups also recognize light pollution as an important issue. For example, the Institution of Lighting Engineers in the United Kingdom provides its members with information about light pollution, the problems it causes, and how to reduce its impact. Since not everyone is irritated by the same lighting sources, it is common for one person's light pollution to be light that is desirable for another. One example of this is found in advertising, when an advertiser wishes for particular lights to be bright and visible, even though others find them annoying. Other types of light pollution are more certain. For instance, light that accidentally crosses a property boundary and annoys a neighbor is generally wasted and pollutive light. Disputes are still common when deciding appropriate action, and differences in opinion over what light is considered reasonable, and who should be responsible, mean that negotiation must sometimes take place between parties. Where objective measurement is desired, light levels can be quantified by field measurement or mathematical modeling, with results typically displayed as an isophoto map, a light contour map. Authorities have also taken a variety of measures for dealing with light pollution, depending on the interests, beliefs and understandings of the society involved. Measures range from doing nothing at all, to implementing strict laws and regulations about how lights may be installed and used. Types. Light pollution is a broad term that refers to multiple problems, all of which are caused by inefficient, unappealing, or unnecessary use of artificial light. Specific categories of light pollution include light trespass, over-illumination, glare, light clutter, and sky glow. A single offending light source often falls into more than one of these categories. Light trespass. Light trespass occurs when unwanted light enters one's property, for instance, by shining over a neighbor's fence. A common light trespass problem occurs when a strong light enters the window of one's home from the outside, causing problems such as sleep deprivation. A number of cities in the U.S. have developed standards for outdoor lighting to protect the rights of the citizens against light trespass. To assist them, the International Dark Sky Association has developed a set of model lighting ordinances. The Dark Sky Association was started to reduce the light going up into the sky, which reduces visibility of stars. This is any light which is emitted more than 90 degrees above nadir. By limiting light at this 90 degrees mark, they have also reduced the light output in the 80 to 90 degrees range, which creates most of the light trespass issues. U.S. federal agencies may also enforce standards and process complaints within their areas of jurisdiction. For instance, in the case of light trespass by white strobe lighting from communication towers in excess of FAA minimum lighting requirements, the Federal Communications Commission maintains an antenna structure registration database information which citizens may use to identify offending structures, and provides a mechanism for processing citizen inquiries and complaints. The U.S. Green Building Council has also incorporated a credit for reducing the amount of light trespass and sky glow into their environmentally friendly building standard known as LEED. Light trespass can be reduced by selecting light fixtures which limit the amount of light emitted more than 80 degrees above the nadir. The IESNA definitions include full cutoff, and semi-cutoff. Over-illumination. Over-illumination is the excessive use of light. Specifically within the United States, over-illumination is responsible for approximately 2 million barrels of oil per day in energy wasted. This is based upon U.S. consumption of equivalent of 18.8 million barrels per day of petroleum. It is further noted in the same U.S. Department of Energy source that over 30% of all primary energy is consumed by commercial, industrial and residential sectors. Energy audits of existing buildings demonstrate that the lighting component of residential, commercial and industrial uses consumes about 20 to 40% of those land uses, variable with region and land use. Thus, lighting energy accounts for about 4 or 5 million barrels of oil per day. Again, energy audit data demonstrates that about 30 to 60% of energy consumed in lighting is unneeded or gratuitous. An alternative calculation starts with the fact that commercial building lighting consumes in excess of 81.68 terawatts of electricity, according to the US DOE. Thus, commercial lighting alone consumes about 4 to 5 million barrels per day of petroleum. In line with the alternate rationale above to estimate U.S. lighting energy consumption, even among developed countries there are large differences in patterns of light use. American cities emit 3 to 5 times more light to space per capita compared to German cities. Over-illumination stems from several factors: not using timers, occupancy sensors or other controls to extinguish lighting when not needed, improper design, especially of workplace spaces by specifying higher levels of light than needed for a given task, Incorrect choice of fixtures or light bulbs, which do not direct light into areas as needed. Improper selection of hardware to utilize more energy than needed to accomplish the lighting task. Incomplete training of building managers and occupants to use lighting systems efficiently. Inadequate lighting maintenance resulting in increased stray light and energy costs. Daylight lighting, demanded by citizens to reduce crime or by shop owners to attract customers. Substitution of old mercury lamps with more efficient sodium or metal halide lamps using the same electrical power. And indirect lighting techniques, such as illuminating a vertical wall to bounce light onto the ground. Most of these issues can be readily corrected with available, inexpensive technology, and with resolution of landlord-tenant practices that create barriers to rapid correction of these matters. Most importantly, public awareness would need to improve for industrialized countries to realize the large payoff in reducing over-illumination. In certain cases, an over-illumination lighting technique may be needed. For example, indirect lighting is often used to obtain a softer look, since hard direct lighting is generally found less desirable for certain surfaces, such as skin. The indirect lighting method is perceived as more cozy and suits bars, restaurants and living quarters. It is also possible to block the direct lighting effect by adding softening filters or other solutions, though intensity will be reduced. Glare can be categorized into different types. One such classification is described in a book by Bob Mason, coordinator for the British Astronomical Association's campaign for dark skies. According to this classification, blinding glare describes effects such as that caused by staring into the sun. It is completely blinding and leaves temporary or permanent vision deficiencies. Disability glare describes effects such as being blinded by oncoming car lights, or light scattering in fog or in the eye, reducing contrast, as well as reflections from print and other dark areas that render them bright, with significant reduction in sight capabilities. Discomfort glare does not typically cause a dangerous situation in itself, though it is annoying and irritating at best. It can potentially cause fatigue if experienced over extended periods. According to Mario Motta, president of the Massachusetts Medical Society, glare from bad lighting is a public health hazard, especially the older you become. Glare light scattering in the eye causes loss of contrast and leads to unsafe driving conditions. Much like the glare on a dirty windshield from low-angle sunlight or the high beams from an oncoming car. In essence, bright and/or badly shielded lights around roads can partially blind drivers or pedestrians and contribute to accidents. The blinding effect is caused in large part by reduced contrast due to light scattering in the eye by excessive brightness, or to reflection of light from dark areas in the field of vision, with luminance similar to the background luminance. This kind of glare is a particular instance of disability glare, called veiling glare. Light clutter refers to excessive groupings of lights. Groupings of lights may generate confusion, distract from obstacles, and potentially cause accidents. Clutter is particularly noticeable on roads where the streetlights are badly designed, or where brightly lit advertising surrounds the roadways. Depending on the motives of the person or organization that installed the lights, the placement and design can even be intended to distract drivers, and can contribute to accidents. Clutter may also present a hazard in the aviation environment if aviation safety lighting must compete for pilot attention with non-relevant lighting. For instance, runway lighting may be confused with an array of suburban commercial lighting, and aircraft collision avoidance lights may be confused with ground lights. Skyglow. Skyglow refers to the diffuse glow that can be seen over populated areas. It arises from light reflected from illuminated surfaces and from light escaping directly upward from incompletely shielded or upward directed light fixtures, which then is scattered by the atmosphere back toward the ground. The brightness of skyglow is affected strongly by the amount of light used, the shielding characteristics of the light fixtures, and by the color or spectral content of the light sources, though it is commonly thought that Rayleigh scattering strongly increases the brightness of skyglow arising from white sources with strong blue and green emission. The dominant spectral effect has been shown to arise from the Perkin effect instead, because of the eye's increased sensitivity to blue and green light when adapted to very low luminance levels. White light sources such as white LEDs contribute significantly more to skyglow than an equal amount of yellow light from sources such as high-pressure sodium, low-pressure sodium, or amber algan LEDs. Skyglow is of particular irritation to astronomers, as it interferes with astronomical observations, but multitudes suffer from the decreased visibility of star-filled night skies. Skyglow brightness can be measured with instruments such as the sky quality meters, or visually using the Bortle dark sky scale. The 9-class Bortle scale rates the darkness of the night sky and the visibility of its phenomena, such as the Milky Way, gauge and shine, and the zodiacal light, providing a detailed description of each level on the scale. Light is particularly problematic for amateur astronomers, whose ability to observe the night sky from the property is inhibited by any stray light from nearby. Most major optical astronomical observatories are surrounded by zones of strictly enforced restrictions on light emissions to limit skyglow. Direct skyglow is reduced by selecting lighting fixtures which limit the amount of light emitted above the horizontal. Indirect skyglow produced by reflections from illuminated surfaces is harder to manage. The only effective method for limiting it is by minimizing over-illumination, but it has to be taken into account that, according to late 2010 publications, Italian regions using full cut-off lighting only does not increase skyglow. Anyway, light reflected upwards by dark surfaces such as roads or buildings can be considered as minor, so debate about the contribution of indirect skyglow will continue. Skyglow is made considerably worse when clouds are present. While this has no effect on astronomical observations, it is very important in the context of ecological light pollution, since cloudy nights in artificially lit areas can be up to 10,000 times brighter than in natural areas. Any organisms that are affected by skyglow are much more likely to have their ordinary behavior disturbed on cloudy nights. Measurement and global effects. Measuring the effect of skyglow on a global scale is a complex procedure. The natural atmosphere is not completely dark, even in the absence of terrestrial sources of light and illumination from the moon. This is caused by two main sources, airglow and scattered light. At high altitudes, primarily above the mesosphere, there is enough UV radiation from the sun of very short wavelength to cause ionization. When the ions collide with electrically neutral particles, they recombine and emit photons in the process, causing airglow. The degree of ionization is sufficiently large to allow a constant emission of radiation even during the night when the upper atmosphere is in the Earth's shadow. Lower in the atmosphere, all of the solar photons with energies above the ionization potential of N2 and O2 have already been absorbed by the higher layers and thus no appreciable ionization occurs. Apart from emitting light, the sky also scatters incoming light, primarily from distant stars and the Milky Way, but also the zodiacal light, sunlight that is reflected and backscattered from interplanetary dust particles. The amount of airglow and zodiacal light is quite variable, but given optimal conditions, the darkest possible sky has a brightness of about 22 magnitude square arcsecond. If a full moon is present, the sky brightness increases to about 18 magnitude square arcsecond depending on local atmospheric transparency, 40 times brighter than the darkest sky. In densely populated areas, a sky brightness of 17 magnitude square arcsecond is not uncommon, or as much as 100 times brighter than is natural. To precisely measure how bright the sky gets, nighttime satellite imagery of the Earth is used as raw input for the number and intensity of light sources. These are put into a physical model of scattering due to air molecules and aerosols to calculate cumulative sky brightness. Maps that show the enhanced sky brightness have been prepared for the entire world. Inspection of the area surrounding Madrid reveals that the effects of light pollution caused by a single large conglomeration can be felt up to 100 km away from the center. Global effects of light pollution are also made obvious. The entire area consisting of southern England, Netherlands, Belgium, West Germany, and northern France have a sky brightness of at least 2 to 4 times above normal. The only places in continental Europe where the sky can attain its natural darkness are in northern Scandinavia and in islands far from the continent. In North America the situation is comparable. There is a significant problem with light pollution ranging from the Canadian Maritime Provinces to the American Southwest. The International Dark Sky Association works to designate areas that have high-quality night skies. These areas are supported by communities and organizations that are dedicated to reducing light pollution. The National Park Service Natural Sounds and Night Skies Division has measured night sky quality in national park units across the U.S. Sky quality in the U.S. ranges from pristine to severely degraded. The National Park Service Night Sky Program monitoring database is available online. Light pollution in Hong Kong was declared the worst on the planet in March 2013. In June 2016, it was estimated that 1/3 of the world's population could no longer see the Milky Way, including 80% of Americans and 60% of Europeans. Singapore was found to be the most light-polluted country in the world.